All right, everyone. My name is Susanna Harris, and what the hell is up with 3D printing of bones? I'm pretty excited about today's episode. I've gotten to play with some 3D printers. I obviously have bones, but the idea that we could actually use those things together, that we could 3D print bones, we could kind of create our own body parts. I don't even know what this means. So, luckily, we have an expert with us today. That's the point of these Ask Me, I'm a Scientist episodes, where I invite different people on to just talk about what they are experts in. And it gives you a chance to ask questions. Remember, you can drop those over in the chat whenever you want to. You can also go ahead and follow me on social media so that you know when these episodes are coming out and you have an opportunity to ask questions in advance. But let's get back to 3D printing of bones. So on our episode today, we have Sean Bittner, who is a graduate student in bioengineering at Rice University in Houston, Texas. And we're going to be talking about using 3D printing and these different kinds of materials that you can actually use to build scaffolds, for human tissues like bones and even cartilage. I'm also really excited because Sean is into something that is very near and dear to my heart, which is creating structures to support graduate students. And yes, that was a play on words. I am not sorry. So Sean is really interested in helping graduate students succeed by acting as a coach, acting as kind of a guide to getting through to the next step. And so we are going to be dedicating some time to that topic as well. So without any further ado, let us invite Sean right on. Hey, Sean, thank you so much for being here.
Hey, Susanna, thanks for having me.
Oh, you're so welcome. It's an interesting time for everyone, and like we were talking before the show, I think we've got this idea that we need to somehow be more productive. And so that's another reason why I was so excited to talk to you about your productivity as a grad student, but also all of these amazing things you're working on in terms of supporting others and even thinking about what productivity means. So let's see here. I have so many questions for you, but I first want to start with the really basics of what is 3D printing. This is a big
Sure.
buzzword, and I think for a while I thought of it as puzzles, what does
Yeah.
this look like? But yeah, so just in general, what is 3D printing? What is going on with that?
Yeah, so it's a good starting question. Kind of broadly, 3D printing is any method that makes a 3D construct. So you were saying scaffold earlier. So normally the way that that works is you have some material, you want to make it into some type of 3D model or build, and then you print it out. The type of 3D printing that I do in particular is called extrusion printing. And that's basically like taking a hot glue gun and kind of pushing out whatever material you're using into a shape.
Okay.
Uh, and 3D printing is really important and cool, and I think interesting for a lot of people now because it's been used in like metals and plastics industries for 15 or 20 years, but now people are using it for more medically related kind of intents, I guess.
Mm-hmm.
So that's moved from like printing little implants and also printing like surgical tools to now actually printing like tissue replacements that can go into people.
So in terms of, we call this printing, and I love your example of basically a glue gun that you're kind of drawing these designs and making different shapes. So it sounds like it has this relatedness to printing sort of because you have this design already, and then instead of ink, you're just putting different kinds of materials. Is this always just like plastic?
Yeah, so yeah, it actually can be a lot of different things, and the like type of 3D printing that you do will change depending on what material you want to print. And then also from a plastics standpoint, so there are some plastics that are like plastics in toys and like consumer goods and stuff. A lot of that plastic is actually toxic to you if it were in your body. Like it's fine to have and hold and all of that, but if it were inside of you, it's not great for you.
Okay.
There are other plastics that are biocompatible. They're FDA approved. You can put them into the body. They either don't do any damage or have a good thing happen. Those are the types of plastics that we use in printing.
Okay.
And almost all of them follow the same kind of pattern of you heat them up, they liquefy, you print them into a pattern, and then they cool and harden.
Okay. Okay. So And that idea of biocompatible just means, your body's not going to throw it away. Or I guess, it's not like your body's just going to dig it out of you and throw it away, but rather your immune system, the natural defenses, they're not going to attack it like it's some
Right.
scary foreign object.
Yes. Yeah.
Okay, cool. Because I know that's something where, and I don't know much about how we can actually use different kind of human transplants in terms of like bones and cartilage, but I do know that's a big problem. Is you have to find this very careful match. Is this something that the 3D printing has an advantage with?
Potentially. So you still have to, like you said, take that into consideration of, okay, we want to make sure that the body isn't going to attack whatever you're putting into it. And more than that, like you want it to actually heal, right? Because if I put something into somebody's body and it doesn't heal, then it just kind of sits there. That's not ideal either. But you definitely avoid some of that kind of grafting problem of like a mismatch or just not being accepted by the body. Some people do traditional like bioprinting, which means they're actually printing cells. Then you do kind of have some of those considerations, right? Because now you have live cells that are being put into somebody else's body.
Yeah.
And that adds a whole other layer of complexity.
Yeah, and that actually relates to this question that just came in from Matthew DeForest. Asking, is the 3D printer itself sort of this off-the-shelf, makes me think of Walmart, but, is it something you can buy from Amazon? Or does it have to have special parts or design for what you are doing? And we'll get into kind of what you are specifically doing, but can people just be printing their own bones at home? Why you would do this? I'm sorry, I just realized what I just said. That sounds horrible, but go ahead.
Theoretically, I guess.
I guess that's not really the barrier to entry in this point, right? It's not the printing. If you're reconstructing your own body, okay, all right.
Find a good shady surgeon friend, I guess, to help. Yeah, so no, it's a good question. So 3D printers are commercially available now because of how common they are. Some of the cheapest ones are fairly inexpensive. The like tissue-based type of printing that I'm working on, there's nothing unique to the like super fancy industrial 3D printers that requires you to use them. In fact, many labs that are either smaller or don't have as much funding as like larger brand name labs create their own 3D printers. So they will actually get a 3D printer, print the exact pieces and parts that they need for a new one, and then build it and start printing with it.
That's so cool. And I know this has applications to space, right? Where you could make new machines out of the machines, which is like, it's so related to how cells work. And I could probably we could talk about that for 3 hours. So, and I guess related to that, one of the benefits of this 3D printing of biomaterials or materials that we would need to help ourselves heal is that, you could technically probably create these things anywhere that you had a 3D printer, whether that's space or rural areas, as long as you had the materials, right?
Yeah, so the goal, I mean, there's a lot of goals, but one of the goals of 3D printing is to make everything more accessible. So, you mentioned space, like if an astronaut goes up in a space shuttle, instead of bringing up all of the tools that they need, if they bring a 3D printer and some rolls of material, they can print whatever they need once they're there. And also, kind of like you mentioned, the low resource setting, again, that's an area where once you have the initial investment of the printer, now it's relatively inexpensive to get kind of any cheap or inexpensive or easy to make thing that you would need. And so in like a medical setting, we talk sometimes, you mentioned before about transplants and grafts. I mean, the ultimate goal is kind of on-demand transplanting and on-demand like tissue printing. We're not there yet, but like the idea would be I could come into an emergency room or a surgeon's office or somebody and say, oh, I have this problem. Can you help me? And however long it takes to print, they would print this piece. They go in and implant it in me and I'm, stitch me up, good to go, right? We're not there yet, but I think that's the like long-term goal.
So, and I'm assuming this has to do with your specific research,
Yeah.
and what is the goal of your research? Are you the one who is going into hospitals and making this stuff happen? Are you doing testing of these different biomaterials? What are you focusing on?
Yeah, so good question. I'm more on the characterization side. So I'm taking different materials and printing them into these constructs and then trying to really just model their material properties. So a couple years ago, last year, I did a couple of studies on different polymers and ceramics. And so, like, your bones are largely ceramic composed.
Oh,
And the goal was, okay, how if I put some cells onto these and let them grow, like, do the cells stay the way that they were? Do they turn into bone cells? Like, and if they turn into bone cells, how mature of bone cells do they become? And so I have done some bone research, and now I'm moving a little bit towards the cartilage direction.
hmm.
Um, Cartilage is really difficult to heal. Anybody that knows somebody with knee problems knows that the cartilage doesn't really grow back very well. And kind of our goal is, okay, if you look at the clinic and see how many people have cartilage problems, we need a material-based method or a cell-based method to fix that. It's not going to be only surgical. So we're trying to work on, okay, what materials are good for this? What other things do we need to put into it to make that work? Those kind of questions.
Yeah. So, and we're talking about scaffolding, right? I guess the purpose for that is so that you don't just have like a big blob of cells. Why do they need something to kind of shape them?
Yeah, so good question. There's kind of two reasons. The first one is a little bit more just kind of like basic biology level. Like, there's cells that need some type of cues from like the substrate or the scaffold in order to know what to turn into. So if you have an open space in a bone, like if you have a fracture in a bone and you put a scaffold there, that material has to match the properties of the bone, or any cells that go there and try to grow on it aren't going to become as bone-like as the other ones. And like, it might not grow well into the other bone that's there. And then you have that same issue where the body is like, oh, I don't know what this is. This doesn't feel right. We're just going to get rid of it. So that's one element. The other element is kind of long-term thinking in the clinic. If a patient comes in and they have a defect or like a fracture in their arm or their leg or something, it might be nice to know what the kind of exact dimensions of that defect are, because theoretically, like, part of 3D printing is designing, and theoretically you could take that shape and just like draw it up and then print that exact shape.
Yeah.
So that's kind of why we want a little bit of shape specifics there.
Interesting. And I think we got this question from Bruno Leonardo asking, can induced pluripotent cells be used in bioprinting currently, at our current state? And I would love for you to also kind of tell us a little bit about pluripotent cells.
Yeah, so the short answer is probably, but I'll go a little bit more in detail
That
than
would be
that.
great. You just leave it there. Probably. Anyway, next
No,
question.
yeah. Yes, move on. No. So yeah, the idea of pluripotent stem cells is these are cells that can differentiate down or become different types of primary cells. There's a number of different types of potency. The the important question for that, or like the important kind of underlying piece of that question, is if you have tissues that are complex, like most tissues are, you'll need different types of cells. So if you look anywhere other than cartilage, so if you look at bones, you look at the heart, anywhere, you'll see more than one type of cell there. And so it's important to know, like, okay, if I have two different cell types or three different cell types in a place, like, what do I need to do? Do I need to like source primary, so like the adult version of the cell for all of them and put all of them in there? Or can I just take a cell that can become like a stem cell that become multiple different kinds of cells and just put them there and they'll know or learn like which cells to become?
Well, I
Um,
guess that could go really wrong, huh?
right, exactly. Yeah. Yeah, that's what I was going to get to, is it's potentially difficult, right? There's a lot of research groups doing a lot of cell printing. So I personally don't, because from a like approval and materials perspective, like If I just have a material that's off the shelf, that's already FDA approved, it's much easier to get that application to later be approved itself. But cell therapies can have really awesome impacts. I think the question still is, what happens when you print them? Do they learn to become the right type of tissue? Probably. But like you said, there's also the potential that they become the wrong kind of cell. You might get some bone cells in like what's supposed to be cardiac tissue. Like that's not great. Right. Like
Yeah.
I'm saying that jokingly,
No,
of
no, no,
course. I'm
no.
not
Yes,
trying
yes,
to,
yes. You're not
yeah.
minimizing it.
Uh,
It's
no,
but
yeah.
it's what else are you gonna say, right? Like you have to have some sort of. I feel like, especially in grad school, you have to have some sort of humor about
Right. Yeah.
possible directions of what you're doing.
Yeah.
Um,
Yes.
and talking all the way through this, I'm so excited in a few minutes to get over to your other work
Yeah. Yeah.
with leadership, because everything you're talking about as far as having structure and helping, that sort of determines what a cell becomes.
Mhm.
So many analogies going on through grad school. But
Yeah.
before that happens, I want to make sure to get some of these questions that came in through Instagram.
Sure. Sure.
People were super excited about this. So let's see. Wow, it's so interesting. Um, Someone asked if they could be a unicorn. I feel like that might be outside the realm. Uh, one of the questions is actually Thiago. He was on an episode a couple episodes ago, Arzua, and he's bringing up something that I wanted to dig in deeper, actually. It says, bones are cool and all, but could we do cartilage? So you did mention this. You kind of already answered this from a totally naive perspective, which is where I'm coming from. Why is cartilage so different than bone? The only thing I can think of is sharks.
Okay. Yeah. No. Good question. So, again, probably. So cartilage is different than bone for a lot of reasons. Bone is much stiffer and in many ways stronger than cartilage is, but also importantly, cartilage doesn't have any blood vessels in it. So normally when cells are damaged and try to heal, there's this need for like blood and oxygen and nutrients to come to that space. And cartilage doesn't have any blood vessels in it. And so when the cartilage gets damaged, that's it. Like it's just damaged. People that have osteoarthritis, their cartilage is literally degrading, and then their bones start to like scrape together, and that cartilage never forms again. Um, and so it's different because like if I'm making a scaffold for cartilage, I need it to have some holes in it. We call that porosity,
Mm.
because I need any cells that are gonna go in and like enter and sit there to be able to do that. Right? If it's just a solid block, they're gonna have a hard time getting in there.
Mm-hmm.
But if there's too much porosity or the pores are too big and too many of them, the cells are not going to recognize that as cartilage because they're going to say, oh, this is a perfect shape and size for a blood vessel. Let's become that type of cell instead. So,
Ugh.
yeah, what the kind of focus of my thesis and several other people's theses now is, okay, yeah, bone is great, but kind of been there, done that a little bit, and cardiac tissue same, but like let's focus on cartilage because it's so much more difficult to make that.
Huh, that's super cool. And yeah, it's a really good point, because I know a lot of people, like you said, with knee issues, with joint issues. Um, and it's always baffling to me that there aren't better treatments. We've got like
Yeah,
topical rubs and take a leave and things like that. So I think that could, it sounds like that could make a huge difference in people's lives if we had better options.
right, right.
All right, let's see. I love when people ask us questions. Okay, I do want to ask the question, which you already saw, that came into Twitter, that was
Oh yeah.
fairly tongue in cheek in terms
Oh
of.
boy.
So the joke was this person. I should pull it up so I can give them credit. Um,
Yeah, yeah.
it's I love the people on social media. They are some of my favorite people. And so this question was the tongue in cheek part was, we asked what questions people have about 3D printing, and Jan, sorry, Jean. Wow, it's literally spelled like pants. Uh, Gene Man Guy, which who knows, says, "Can we print spines?" Just asking for some politicians. So I'm going to take a guess that we cannot print moral structures, but Yeah, how many bones could we print? Can we just like turn? Could we turn worms into snakes?
Uh,
I have been in my house for so long. I am sorry, but
yeah, us too. um, so on the like number of bones question, printing an actual like full bone is extraordinarily difficult. Just the amount of material and the length of time it would take, and like hoping you don't mess anything up, and all of that is super super hard. So also thinking about the spine, like the spine is not just bone; it's bone and cartilage and nerve cells and all of this other crap. Um, it's possible theoretically. It would just be really technically difficult, and I don't know everything obviously, but I'm not super familiar of anybody that has gotten that much like complexity yet.
yeah.
People are printing individual like cervical spine discs. That's actually pretty badass, to be
Yeah,
honest.
because they're super
Uh,
like specific in terms of shape and size,
yes,
right?
yes, yes. So that is actually happening. It's super super cool. Not here. I'm trying to remember where. I'm gonna butcher this. Australia, maybe. No, I somewhere they did one of the first like
Ooh,
implantations of a printed cervical spine disc,
awesome.
and it was awesome.
All right, I'm writing that down, and we will find that and add it to the links below once this goes up
Yes,
permanently.
or
Yeah. Okay. Let's ask one more question with that. I like this. So Costin97 on Instagram says, "Can we 3D print exoskeletons and jetpacks?" Which is quite the combination. But what is? I'm going to repurpose this question
great.
because I think right we can 3D print these like giant external things, right? Like people have 3D
Sure,
printed the most bizarre stuff.
sure. Yeah.
But why, if we can 3D print external things, why even worry about bones? Like, why don't we kind of become just bionic humans?
I mean, I think that there's again a little tongue in cheek, right? I think there's maybe some ethical issues there, and maybe some moral conversations to be had. Um, kind of like joking aside, the goal ultimately of like tissue, we call it tissue engineering, but creating tissues to help the body heal itself is there's kind of an underlying assumption that helping the body heal itself is a better choice than like just ignoring that and having an alternative solution. And I say that because like anybody that's broken a bone, anybody that has really had any type of difficulty with disability, I think is going to have that thought.
Mm,
And it's a kind of a larger conversation of like, okay, what if we could just like, okay, we can't heal you, but we can make your life so much better by putting you in X or Y or Z. Great conversation to have, and like that person can make that choice for themselves, which is great. But we also probably should have the opportunity at least to try to let the body do its work first
mm,
before we just kind of be like, well, that's it for that part of the conversation.
sure.
Yeah, that's the jetpack thing is funny.
I like the combination of exoskeleton jetpack. I
Mhm.
am now a beetle. Um, so, and just to clarify, everyone, we cannot make worms into snakes. I mean, you could put a skeleton in a worm, which would be really creepy anyway, but that does not make it a snake. Anyway, I do want to go over before we run out of time because this
Yeah,
is
yeah.
now.
Sorry.
I mean, no, it's really cool and it gives me a really creepy internal feeling. That kind of dissonance between thinking the science is really cool, but then also thinking about like creating external bones that would go in my body. That feels weird. Um, but let's switch over and on top of all this research you're
Yeah, yeah.
doing, on top of the fact that you are a graduate student, you're like doing bioengineering is just beyond cool to me because you have to learn about bones, but you also have to know about all of this computer stuff and math and whatever. Why then are you dedicating a significant amount of your time to being kind of a career coach for graduate students, or thinking about how to better support graduate students?
Yeah, no, I love the question. So, Again, kind of tongue in cheek, you mentioned Twitter and Instagram. The like academic community on social media is the best thing I've ever found, I think. Just in terms of energy and excitement and solidarity and all of that. But one thing that I noticed that keeps coming up is this idea that, hey, the path to from PhD to academic, so the path to lecturer, the path to researching professor is not an easy one, certainly, but it's fairly transparent. Not again, it's not necessarily straightforward, but people generally understand. I get my PhD, I do a postdoc or two or three or X.
Forever, yeah.
Yeah, exactly. And that's a separate conversation about availability of jobs. But PhD, postdoc, professorship somewhere. But a lot of people are saying, hey, like if I don't want an academic career, like if either I'm sure I don't want that, or I'd like to keep my options open. Sometimes I think people are saying like, I don't really know what to do.
Yeah.
And at a lot of institutions, this is the case. Like, we are not necessarily equipped to handle that, right? Because I think there's still this model of like, oh yeah, you got a PhD, you're going to go do research and be a professor, and all of that is great. But overwhelmingly now, people are going into industry. Some of that's because they have to, right? I mean, there are far fewer jobs than there are PhDs in academia, but also interest, right? I mean, like with a PhD, you can do not only research, you can do research in a lab, research in industry, you can do consulting, sales, kind of in the realm that I'm moving towards, you can do interpersonal development. Like there's so much that we can do, but there's not always, I think, good infrastructure for like meeting students where they are and supporting them in making those career choices.
And going back to what we were talking about before, I love how much your work kind of overlaps with itself. That if you do have the right surroundings, if you do have the structure, it's going to be a lot easier, a lot more possible to end up kind of as the future that you want to be. And so, talking about those sort of tangible ways or those more streamlined ways, what do you see as being necessary? What do you think that, what are you offering? What are you looking into? But also, what could schools be doing differently?
Yeah, great question. I'll kind of split it up into two. I'll talk about the things that I've kind of invested in, and then I think things that are more generalizable. So for me, the kind of time that I've invested has been in three areas. One has been just kind of general communication skills improvement. So we have a really awesome writing center at my campus. I do some volunteer work there, but what we do is help students that it's not necessarily a language thing or a quality of writing or presenting thing, but basically you come in and say, hey, I am working on this assignment, project, publication, whatever, and I need some help. And I think that from like a teaching standpoint has been really helpful, not only to the students, but to me, because it like kind of reinforces in me this idea that like there are students here, and if this service wouldn't here, there would not be anybody to help them with this, whatever they're working on. Right. The second thing has been getting involved in my community. So I have been volunteering for just about a year now in, we call it an innovation nonprofit, but there's a small company in Houston that does work with the life science community. And it's only graduate students in the company. It's grad student run, grad student operated, the whole bit. And basically what we do is kind of connect the up and coming ideas and companies in this space with grad students that are looking to get experience and knowledge and translatable skills and all of that. And then the third thing has been, you've mentioned a couple of times, this idea of leadership coaching. So I'm now trained as a leadership coach, which means that I've been through a 60-hour training class. It's called the International Coaching Federation. Sorry.
Yeah, the IFC, right? Or ICF?
ICF, yeah. So I went through a 60-hour training class that they've approved. And basically now what I can do as a leadership coach is work with students and kind of newer graduates. That's the space that I like to work in. And help them kind of figure out, okay, what are like leadership goals and ways that we can strengthen you as an individual, as a researcher, as a contributing person in society. Um, that has been really incredible for me. Like I went through coaching myself before becoming a coach, and just the I think the base opportunity to just say like, oh, I would like to work on communication. I would like to work on delivering feedback. I would like to work on managing a team or accountability or like all of these skills that are so integral to like not only being a self-sufficient adult, but also like a awesome person in industry and a job anywhere. We don't ever get formal training in. And so like we don't ever learn, oh, this is how you deliver feedback to somebody
Oh
effectively.
man, I have never learned that in academia. I have to. Wow. Yeah. I nope. Mm-mm. Um,
Um,
yeah.
yeah, I think part of it too is, and this is kind of it was a weird conversation for me to have initially. And if it challenges any viewers, like, awesome, cool. Um, when I started my leadership coaching training, there was this kind of question at the outset of like, oh, what's your picture of a leader, right? Like, no lead in, no like bias or anything. Like, what's your inherent picture of a leader? And unfortunately, often that picture is male, usually white, and unfortunately yells a lot.
Mm-hmm.
That's the picture, right?
Mm-hmm.
And that's the picture that's been pervaded for the last 40 years or more, right?
Yeah.
Um, and so this idea of leadership coaching is okay, actually, what makes a leader can be taught. It's not inherent to somebody. It's not like, oh, you're born with it or you don't have it.
Mm-hmm.
And if it can be taught, it can be developed, right? So if leadership is this just kind of nebulous thought of like, oh, somebody has it or they don't, like that's very exclusionary. Whereas I'm operating from the standpoint of like, we can work together and make you a better leader in whatever capacity you want to work in, and like everybody can do that.
Mm. Yeah, I mean, I love that, and I love to hear that you've dedicated time to really learn that sort of stuff. I've had the opportunities to work with an executive coach and a life coach, kind of different realms, but you know. I didn't quite understand what that meant, and I feel like we could probably do an entire episode of that. Maybe we'll find a time to do that because that would be great. But I want to
I'll
make
be here.
sure, you know, uh, if people want to ask you questions about this, if they want to get to know more about you, we've got the links down below you in terms of where people can find you. Is it cool with you if people reach out?
That's fantastic.
Okay.
Yeah, definitely reach out. Please ask questions. If you want to do coaching, great, I'm here for it. If you want to just ask what that even means, awesome. Send me an email, send me a DM. Like,
Great.
I'm here.
That's so cool. And the last question I always like to ask the guests is, related to either topic. We've got a couple, so you can pick and choose. What are you currently teaching yourself about? It's clear that you've been active in learning everything from biomedicine to supporting biomedical students. Um, what are you currently trying to learn? What are you Googling about this?
Yeah, so I'm Googling a little bit of both. In the printing area, I'm Googling what am I missing out on? My lab has a lot of good experience, but not the longest experience. And so like for people that are older and more established than we are in this specific space, like what have they been doing and what can we get to? In the leadership coaching and like development space, a lot of what I've been Googling and learning about recently is okay, I'm a trained leadership coach. How can I best meet people
Mm,
as individuals, right? There's this idea of like coaching as this nebulous, like I tell you what I think you should do and you do it.
hmm
And that's not the most effective way to coach people. The best way to coach them is like, I am simply a learner and observer of what you're going through, and I can meet you where you are.
mm.
And so looking at resources that have helped me kind of model my coaching style after that idea.
That's awesome. It's so cool to hear about all the kind of personal discovery you're working on, and that you're passionate about how others can get there as well. So, Sean, thank you so much again. It was really cool to talk to you. So many questions that we could talk for hours, but yeah, thank you for coming on here. Please let me know if there's anything I can do to support you in the future. But I hope that you have a great rest of your day.
Yeah, thank you for having me. You too.
Okay, everyone, so that is the end of today's episode on printing bones and creating structures for graduate students to grow into whatever type of grad student they want to be. Uh, Thanks again for watching. Please remember to like and subscribe. That just helps to tell me that I should keep going. If you or anyone you know has some awesome science to talk about, send them over my way. I love doing this. It's really cool. It's a great distraction from whatever else is going on. And hopefully, y'all are learning just as much as I am. So until the next time, take care and go learn some interesting science. Bring it back with you. All right. Bye, everybody. Oh no, it won't end. Oh, this is the nicest awkward ending ever. Okay. Bye. Okay, cool. We should be done there.